So in the previous session, we learned that data can be classified as categorical or numerical. And we also explore the difference between discrete and continuous data. But knowing the type of data isn't enough. There is another important classification in statistics called the levels of measurement. Understanding measurement levels help you choose the right statistical methods, create meaningful visualization, and avoid incorrect conclusion during analysis. So in this lesson, we will explore 4 levels of measurement in simple and practical way. Let's begin. So what are the levels of measurements? Every variable carries information, but not all variables provide the same amount of information. For example, knowing someone's favorite color is different from knowing their monthly salary. Similarly, ranking students in a competitive competition is different from measuring their exact scores. To distinguish between these differences, statisticians classify variables into 4 levels of measurements, that is, nominal, ordinal, interval, and ratio. The first two belong to qualitative data, while the last two belong to the quantitative data. Let us understand each step by step. So, nominal level. The nominal level is the simplest level of measurement. The word nominal comes from the idea of naming or labeling. Variables at this level simply divide the data into different categories. There is no natural order between the categories. For example, consider the following programming languages: Python, Java, C++, JavaScript. These are simple different categories. None of them is mathematically greater or smaller than another. Similarly, consider the blood groups A, B, AB, and O. Again, these are labels, not ranking. Other examples include eye color, nationality, vehicle brand, browser type, payment method. Without nominal data, you can count how many observations belong to each category, but you cannot perform mathematical calculation on the values. So next we will discuss about the ordinal level. Now let's move one step higher. Ordinal data also consists of categories, but this time the categories have a meaningful order. However, while the other order is known, the exact difference between the category is not. Imagine an online shopping website asking customer to rate their experience. The options are very poor, poor, average, good, excellent. Clearly, these responses follow a logical order from the lowest ranking to the highest ranking. That's why ordinal data tells us which category comes first, but not how much better or worse one category is compared to another. Other common examples include education level, customer satisfaction, movie ratings, competition rankings, military ranks. Whenever you can arrange categories from lowest to highest but cannot measure the exact distance between them, you are dealing with the ordinal data. So now we will move towards qualitative data to quantitative data. So far we have discussed variables that describe categories. Now let's move variables that represent actual numerical measurements. These are called quantitative variables and they are divided into 2 levels, interval and ratio. Although both use numbers, there is one very important difference between them. Interval level. An interval variable has equal spacing between values, which means the difference between two numbers is meaningful. However, it does not have a true 0 point. The most common example is temperature measured in Celsius or Fahrenheit. Suppose today's temperature is 20 degree and tomorrow it's 30 degree. We can confidently say that tomorrow is 10 degree warmer, but we say it's 50% hotter. Can we say it? No. Can we say that 40 degrees Celsius is twice as hot as 20 degrees Celsius? Again, no. The reason is simple. The 0 point in the Celsius and the Fahrenheit scale does not represent the complete absence of temperature. It's simply an arbitrary point chosen when the scale was created. Because the 0 isn't absolute, ratio comparison don't make sense. Another example of interval data is calendar year. The difference between the year 2010 and 2020 is exactly 10 years, but saying the year 2020 is twice the year 2010 has no practical meaning. Hope the point is clear. Now, the ratio level. The ratio level includes everything an interval scales has plus one additional feature, a true zero. A true zero means the value 0 represents the complete absence of the quantity being measured. This allows us to make meaningful ratio comparison. For example, consider height. If one person is 180 centimeter tall and another is 90 centimeter tall, it's perfectly correct to say that first person is twice as tall. Similarly, if one object weight is 20 kilogram and another weight is 10 kilogram, the first object weighs twice as much. So this work because 0 height and 0 weight represents the complete absence of those measurements. Common examples of ratio variables include height, weight, distance, time, duration, income, age, number of products sold, salary, speed. Since these variables have a meaningful 0 point, we can perform all mathematical operations including ratio comparison. So many students find interval and ratio confusing, and that is true. So let's look a famous example. Temperature measured in Celsius is an interval variable. Temperature measured in Kelvin is a ratio variable. Why? So the answer lies in a fact that because 0 Kelvin represents absolute 0, but theoretically point where molecular motion reaches its minimum possible state. Nothing can be colder than absolute 0. Since Kelvin has a genuine starting point, ratio comparison becomes meaningful. For example, 200 Kelvin is twice much as 100 Kelvin in terms of absolute temperature. That comparison isn't valid using Celsius because 0 degrees Celsius is not absence of temperature. This example clearly illustrates the difference between interval and ratio measurement. So let's do a quick comparison of all four levels. Now nominal. Under the nominal category we have order. No, we don't have order. We have only categories. Okay, no order. Examples are blood, group, city, browser, eye color, etc. Now in ordinal, categories with order. Difference between category is unknown. Okay, the difference between the categories is unknown. Example, satisfaction, ratings, education level, rankings. And third is interval. Now in interval, ordered numbers. Intervals are the ordered numbers. Equal intervals. Yes, equal intervals have. It has no true zero. Yes, it has no true zero. Example are Celsius, temperature, calendar years. Now ratio, ordered, they are the ordered numbers. Yes. Equal intervals. Yes. True zero. Yes. Ratios are meaningful. Yes. Examples are height, weight, age, income and distance. Now question arises, why do measurement levels of measurement matter? You might wonder why statisticians care so much about this classification. The answer is simple. The level of measurement determines which graphs are appropriate, which statistical test you can use, whether averages are meaningful, which machine learning techniques work best, how you should interpret your result. Using the wrong statistical method for a variable can lead to a misleading conclusion. That's why identifying the measurement level is one of the first steps in any data analyst project. So the key takeaways from today's session is that there are four levels of measurement in statistics. Nominal variables classify data into categories without any order. Ordinal variables introduce an order, but the distance between categories isn't measurable. Interval variables have equal spacing but lack of true zero. Ratio variables include a true zero, making ratio comparison meaningful. So once you understand these four levels, choosing the right statistical tool become much easier. So in the next lesson, we will build on the foundation, explore the different types of graphs to visualize data effectively. Thank you very much. I will see you in the next video.